Hi, my name's Derik White. I'm with the Cad Zone out of Beaverton, Oregon, local. Our company has been publishing diagramming software for over 20 years for the crime and crash and fire investigators. Really our goal for over 20 years has been to design products that can do what you need to do as an investigator, creating real world scale scenes that are accurate, but simplifying that process. You know, because as you guys know, it's getting a little more complicated every year. There's new tools and new things to do. And a quick note, we are the makers of the Crash Zone and the Crime Zone. Those programs are identical. So you'll see me showing Crash Zone more than likely. We have the Crash Zone and Crime Zone named differently because we originally came out with the Crime Zone, and when we discovered the reconstructionist market, many reconstructionists called us up and said, we will not use a program where in court we have to say we created a diagram in a crime zone. So there you go. So it's all just a marketing thing. So if you don't have one of our programs yet or you're looking at it, either one will work for you. Just pick the name you like. So in this presentation, I want to talk about some of the methods and tools for diagramming using point cloud data, using RCZ point cloud animation. And we're more than just a diagramming program. We're all about creating forensic diagrams, analyzing that data, animating your work to tell the story that you've came up with from your analyzing, and presenting that data, whether it's in a PDF format or a plot. This is just an example of point cloud data, a mock crime scene we took in Colorado last April. And with that data, we were able to create a nice little 2D diagram with bullet trajectories, bodies, evidence markers, and all the furniture. And then this is a 3D snapshot of that data. This is an example of measuring and analyzing your data. In this case, we have a crash, and we're showing the angles used to calculate momentum, speed from momentum. And we can then animate that data and include the point cloud data in it to get a nice complete scene. And this intersection here was actually a big Florida intersection that was shot a couple years ago. So, importing measurements into CAD and into our program in particular, again, our goal is to create accurate real-world scale diagrams we can measure and analyze. And how do we do that? Well, over the years, you know, tape measures, baseline and triangulation, total station, cameras using photogrammetry style programs and importing that data, and now laser scanners. And all these methods are still valid. You still might use the laser scanner and still need to go take a couple of measurements with your tape measure at some point, or combine total station data. So an example here of a scene, create baseline measurements of a body, and then we can take that data and import it directly into our coordinate data table. And then you can see that little tool, it models the drawing accurately, and then it goes right into the diagram. We can import satellite images from Google or Bing from inside the program, and when you place them, they will be to real world scale, and you can geo-reference them, meaning that satellite image will be placed where it's at in true world coordinates. So I could put this image in, and I could add another image and append it to it automatically. And what's nice about this image is, and we saw in Bobby's presentation at one point, if you were missing something from a scan, these are real world scale. You can actually align your scan data or total station data over this image, and then if you were missing some lines or an edge of a building or something, you could trace over this and include that, and then you could hide that on another layer and take measurements off it. Pocket Zone is a product we have that works with total stations. So if you're happy with one shot at a time, that's the way to go. And the method we're all here for. Laser scanner data. So we really saw the need, and I think we always feel like we need to answer this need, to do something, simplify a problem. And when we were introduced to laser scanner data, we felt like we had to come up with a better solution to easily diagram from that data. So we approach it as exactly what it is. These are all 3D points, X, Y, Z data. We want to just connect the dots. So we can create a diagram using any of these methods, independently or combined. And so you could complete a diagram using your point cloud data, but if you wanted to combine total station data to that in the diagram program, you could. And mentioned earlier, if you couldn't register a couple of scenes or you didn't have time to target them, you could create 2 diagrams and merge and align those in the program. So you're not going to find yourself unable to complete a diagram. And here we just have different forms of data on top of a satellite image. So laser scanner data, it's really the evolution of precision forensic diagramming. There's less time involved once you get the process down, the workflow down, less error and more data. You're creating a snapshot of the scene that you'll be able to visit years later. And really, it's the purest form of CAD data. It's X, Y, Z points. So we have a real world scene snapshot.
So easy. A caveman could do it.
That's what we're always aiming for. Of course, that might not always be the truth, but if Bobby can use it, it is that easy. That's what we, so Ron's not here, so. So here I'm just showing we're connecting the dots, and that's what we see, how we see about doing that. So we've got our point cloud system, CZ point cloud, and that is the answer. It's a scanned scene can consist of obviously millions and millions of points. So you've got challenges to overcome. How do we work with this data quickly, fluidly, and deal with an unlimited number of points on machines like this old laptop here? We want our speed, fluidity, and accuracy. So this application takes care of all that, so you can diagram. And what I'm going to do is I'm going to show you some snapshots of what we can do and some movies of what happens, so I don't slow us down and we have time to look at this. So really quickly, this is a part of our office scanned. This is a top-down view. You can see the ceiling and the lights. And so we can quickly clean this up. If you didn't do this cleanup in your processing software, we can do it in here. We're going to hide the parts we don't, or keep the window that we want, that area. Then we're going to turn it sideways, and we're going to actually hide the ceiling, so when we're looking down into it, we're not blocked by the ceiling. And as we do all this, we're not losing any of these points. We're just hiding points, keeping points, bringing points back. It's just to make it easier to work in. We could get a scene like this where you can see there's skid marks and maybe there's mud or a different color, so we can hide colors and bring things out a little bit more. In this case, we have a very complex carpet here, but we're able to hide enough that maybe the blood stains stand out a little more. Night vision, Bobby showed this in his program. This was very important. If you're applying color to your scans, obviously at low level lighting or at night, you're going to get this, and you're going to feel like you don't have anything to work with. But with our night vision mode, we're taking the intensity values from the laser and we're grayscaling them, and you can pull out all the detail you need. This scene here, and that's my youngest son. My two boys love to work for me like this because it's what they do best, lying around. So this room was completely blacked out, and this is a 7-minute single position scan just to see how well it works with the night vision. So I'm going to run this little movie to show you some of the things in action. First of all, when we're working in a scan, we found out very quickly a standard normal cursor wasn't good enough. As you can see, as it moves into the shade, you would start losing it. Now we've built this cursor that no matter where you're at, it shows up. So we're in the dark shadows. Now we kind of have that little night scope effect. Then you move up to the edge, and it helps you line up on the data in the diagram. And literally took probably 36 tries to get the cursor that we felt didn't impede or bug the people that were using it. So I can easily grab the edge of the roadway here, and these are true points. It only lets us snap to cloud points. So this is 3D data, and 3D data. There you go. Mouse navigation. So how do you navigate when you're in the cloud? Well, you just like in our 3D viewer, you keep it very easy. You hold down the left mouse button. You can move up and down, left and right. You can use the mouse wheel to zoom in and out, and if you hold down the mouse wheel, you can pan. So it just really helps you kind of get around and get the view you want before you start drawing. And then kind of the king of the navigation tools is seek, and that sets your rotation point. Click on seek and then click on any place in the like this fire hydrant, and it lets us, everything we do, zooming or rotating, will be about that point until we change it or turn it off. So you don't have to work really hard. Another thing is we're limiting some of the points to make it faster, but we can do a quick high def preview. It's volatile, so as soon as I move, it goes away. But if we need to keep an area up of evidence or something we just want to see while we're moving around, we can do a high def preview window, and that will bring in all the data that's indexed for this cloud and hold it in place there. So while you're diagramming, you just don't need super high density, you just need to see your edges in your data. So then another key and very original tool we have is our mag view window. You bring this tool up, you can adjust with the mouse wheel the magnification factor, the point size, you can move this out of your way. And so instead of zooming in and out all over a long section of roadway, whether it's 100 feet or 300 or 400 feet of roadway, you can adjust your view until you can see like this white fog line here, and you'll notice in the mag view, it's very easy to see the center of the fog line. I could zoom up even more in there if I wanted. So I'm actually clicking and drawing using a curve, and I'm going to stop just short of the crash, then I'll move just beyond it and move through. So you can find a good vantage point and do a lot of your drawing from there. It just saves you a lot of hassle of moving in and out of that. Flip Z. Next, I'm going to change the line type. Everything we do in the diagram program, you'll see in the cloud. So you can see I changed that line to a guardrail. And while we're drawing in the cloud, you're creating your 2D and 3D diagram at the same time. So it's all same time, all real time, and what you see is what you get. Flip Z, we want to draw the roadway, but we have all the trees and all the ghosts and whatever that are in the way. You just hit Flip Z and just turn the world upside down, so to speak. It's just one click, very fast, and now you can see where you're working and maybe avoid some obstacles while you're doing it. Trace 2D, a lot of our customers really want 2D maps or 2D diagrams. So with all this 3D data in there, just flip to a top view, go into our 2D trace mode, and you'll actually be snapping to all the XYZ points. It'll just cut out the Z and put everything down flat on the ground. So you can get a nice map and don't have to worry about lines going all over the place. So WYSIWYG, what you see is what you get. This is a point cloud view, but you can see we've got surfacing and vehicles in there, and so you can see what's happening. We can also transfer points from the cloud into the diagram. Now, the point cloud tool is meant to handle an unlimited amount of points. The diagram program can't handle millions and millions of points, but it can handle a few extra thousand. So if you needed to see some evidence or something important in your diagram, you can actually copy it over, and that's all the 3D points come over. So just a diagram isn't always enough, and so we need to analyze our work. We need to take measurements and determine speeds and trajectories and everything to determine what happened. And of course, that is why the accuracy in real-world scale is vital, and that's what we're getting from the laser scanner data. So here's some of our tools for analysis. We have linear and angular dimensioning. We have a slope calculator tool that gives you all that data that just by clicking on two XYZ data points, 3D points. We have a tool for just by clicking on a skid mark, you can determine speed from skid or multiple skids over multiple surfaces. We can do speed from momentum, critical speed yaw, and we have 4 different methods for doing that. Crush analysis, you're going to need that. Even a profile tool, so if we want to see what the profile of the road or the ditch look like, we can just draw a line across the point cloud and then generate that profile and see, there's the ditch, there's the crown of the road, and get all that measured. More analysis, I'll show a little bit. The body poser. So here's my other son, my oldest son. You can see there's a little, consistency going on here. And the great thing about this was we did this as a test diagram to verify measurements, and we used tape measures and photogrammetry to make sure the scanner was spot on, which it was. So I told my son, you need to lay here perfectly still for 2 scans, and they're going to take 7 minutes apiece. So he put his earbuds in, he said, no problem, and I said, great, well, I'm not going to stand here for 7 minutes, so I walked back to my office and got to work and completely forgot until I believe Mark in our office came in and said, hey, are you working with Alex? Came back, he hadn't moved, but he did mention to me that he had heard the machine beep, so he stuck it out. It took about 45 minutes that time. So we can between any 2 points, we can create a line segment. We can trim or extend those line segments really quickly, and you use trim extend for a lot of reasons, but in this case, trajectory lines. So this helps us quickly generate trajectory lines if we have a couple of points to click between. And then we have our trajectory cone tool. Ken, you'll like this because he prompted me to do this about a year ago or so, or less. And there's always going to be more work on these tools, but this is kind of neat because you get a 5-degree cone. You can adjust the color, whether it's filled or solid in 3D and 2D. And then if you go into 3D, you could maybe do a little more analysis with this and take it wherever you want. So we're seeing a lot of data. And now you can see we've added the point cloud data to the diagram. So there's the diagram, there's the point cloud work, it's all real time. So now data, working with what we have. That's great, these scanners are great, total stations are great. You go out and shoot, and yes, you are probably getting everything, but maybe you do a 2-position scan or a single-position scan. There's a little bit of road or something behind something you can't quite get. We have a lot of tools that are not common in many programs, but some are, and like offset. We could literally have just a single 3-dimensional curve that's the center of a roadway, and just by using the offset tool, if we know that one side of the road is 11 feet 6 inches and one is 12 feet and the edge, we can just click on that and it'll actually offset that 3-dimensional line to whatever value we give it. And then we can quickly click on those lines, change them to any of our 3D line types, which we have hundreds and hundreds of. This is a double solid. Maybe we'll add a guardrail to this one. And you don't need a mouse with this program, it's with your mind. So give me a second. It's hard to talk to you and do a drawing, so cut me some slack. So there you go. And and then I can quickly show you how we could just pick a surface style type and just pick between a couple of entities, these 3D entities, and we could add automatically do a little bit of asphalt surfacing. And we'll do the other side. We're not doing it all at once because there's a crown there. So quick and easy. All right, so 3D Builder. We have thousands of symbols. We have nearly 8,000 2D, 3D symbols. Every 2D symbol has a 3D symbol. Sometimes though you're going to have an odd shape or an odd thing we just don't have. So if you could trace the outline of it, like this is a box that was in that crime scene. It truly was just a cardboard box. It's 4.2 feet tall. I select the outline, use our simple little 3D builder tool, and make a box that's 4.2 feet tall. Now I've got a chair. I do the outline of the chair. I don't have that particular chair on its side. So I'm going to say, well, it's 1.5 feet tall, and I'm going to give it this maybe a darker, I'm contemplating this darker maroon color here for the top face of it and the side, and it looks just like the chair. It's a nice real looking chair. And then I will copy the legs over and elevate them up 1.5 feet, and now we've got our chair. So, and even a curtain. Something as simple as a curtain, you're not going to really have a curtain symbol, but that was a curtain that was traced, and then we just elevated it up 8 feet and gave it the same color. So if you don't have something, you can do that. Now merge and align. Here we know the vehicle, this is an exemplar version model of the vehicle, but the crushed vehicle was positioned there. We had to go and scan and create the crushed vehicle from the junkyard, or the whatever you call it, that place. I can import or merge that in and quickly align it exactly where it is in the diagram. It's not that hard, and that same process could be used for other diagrams. You could merge multiple diagrams and symbols or whatever you want to do. Now, we don't simulate, we animate. So once you've used these tools to determine what happened, your evidence, your skid marks or whatever, you are going to position your vehicles and create animations very quickly based on your results. So you're telling your story. So in this case, we already created the scene with the point cloud, and you can see, oh, okay, there was a road surface. There's a couple of cars, there's a guy wire on a post, there's a tree, there's a sign. Now, what happens if we just tell the animation tool, oh, please insert the point cloud into that? Now you get all that extra, you just get the whole environment at once. And it's not any harder for you to do that. So you create your scene, do all your work, and then when you're ready to create your animations, just tell it to add the point cloud, and it just will automatically pull that data in and create the animation. And finally, and really not least, you've got all this work. Okay, so you've created an animation that's a Windows movie file or an AVI file. You can export that and or send that off to anybody. What do you do with your diagrams? What if someone needs to see a diagram? Well, you can export your diagrams to a PDF file and send those to anybody. You can print out in the program. We have a very simple, easy to use tool since everything's real world scale, you just tell the program what size paper you're printing it to, and it'll tell you what the scale is. 1 inch equals 20 feet, 1 inch equals 50 feet or whatever. And then we have borders, and you can build custom borders and put it around it. And then if you have a plotter or a printer, you can print it out to exact scale. And you can also, when you export it to a PDF, you can say what paper size and scale you want to print it out to, and you can take that file to like a FedEx office, used to be Kinko's, and hand it to them, and they can plot it out for you if your department doesn't have a plotter, and put it on poster board or whatever you need for presentation. And also, all these points, all these curves, lines and arcs and everything you're drawing from the point cloud, you are probably going to have to hand off a point list to somebody. Which points did you use to create the diagram? You don't have to worry about that. Once you're done, you can export to our Cloud Point report with our Cloud Point report tool, and you will save all the data. It'll actually label everything, curve, line, or arc, and you can select any of those in the program and change their description, and you end up with a nice, simple point number, XYZ description file, just like you're used to using, and you can hand that off to anybody. So we are more than just creating diagrams. We want to be able to work, we do work with any form of measured data, and we can help you analyze the scene data, or you have tools for doing that. You can animate your work, and you can present your work. And that's it.